Welcome everybody to my presentation. My name is Vincent Lenders. I'm the director of the Cyber Defense Campus, and I will be presenting some work we have been doing in the area of artificial intelligence, in particular in large language models and how they affect the cybersecurity. So the Cyber Defense Campus is very close to here, so we are here on the same street, 200 meters from here. And we have also office in Lausanne at EPFL and also in Thun, where it's a relatively new organization. It has been founded 2019, almost 6 years ago. And the goal is to strengthen the cybersecurity, the cyber defense of Switzerland. It's attached to the Federal Department of Defense, but it's organized as a public-private partnership with a lot of collaborations in Switzerland and internationally with academia and also industry. We do many different things, from research to innovation to training, but also to penetration testing. We have also a team of security experts that do the penetration testing and the security testing of all the military systems and the systems that are relevant for the cybersecurity of the Swiss government. I want to talk about AI because AI is a very technology that has made a lot of progress over the last years. We can see here how AI over the last few years has been much better at tasks than human intelligence. For example, in 1997, it was the first computer that was able to beat back then the world master Garry Kasparov in chess by a machine developed by IBM. Then another case in 2011, and another machine by IBM that was able to beat the best player in Jeopardy. It's a quiz show that involves understanding text and language. And then 2016, Google developed a machine, a program that was able to beat the best players in Go. And this was back then a surprise because in contrast to chess, where you can basically combine, calculate many different positions, in Go, it's impossible. There are way too many combinations. So you need some kind of intuition. And people thought before it happened that it would be very difficult for a machine to develop this intuition in the game, but it happened. Also 2019, a very interesting point where Facebook back then developed a program called Pluribus, who was able to beat the best poker players in the world. And this was again another surprise because poker requires some bluffing. And back then it was believed that bluffing is a human trait, that humans are able to do this, but not machines. And in order to beat the best players, you need to do bluffing. So this was also a kind of another surprise. And 2 years ago, as all of you know, we had this breakthrough in natural language processing, ChatGPT, developed by OpenAI, who has suddenly created some chatbots that were able to answer questions, solve problems far beyond what sometimes what humans are able to do. And the question is, of course, what will happen next? And in this graph, this is a graph that has been a picture that has been drawn by Max Tegmark, a professor at MIT, who categorizes the difficulty of different problems that can be solved with artificial intelligence. And the problems I've just introduced, they are considered here as the simpler problem because they are at the level of the sea, and the higher you get, the most difficult these problems, these challenges will be. And if you look at the peaks, at the mountains, they're very hard problems for artificial intelligence are things like art, book writing, or science. And the question is how far will it go? And at some point, when we have solved all these problems, this is what we call artificial general intelligence, basically an intelligence that is able to solve all problems, not only a few, far better than what humans can. And when will this happen? There's been in January in 2024, this year, an interesting survey performed by researchers from Berkeley and University of Oxford and University of Bonn, who surveyed basically the best or the top researchers in the AI field, a few thousands of them that publish regularly in the AI community. And they asked a few questions, and one was by then, do they think that unaided machines would outperform humans in every possible task? And they estimated that there is a 50% chance that it will happen by 2047, so not very far from today. And what was interesting by this study is that it was actually done 1 year previously, and 1 year before, in 2022, the predictions were 2060, and now they believe it will be by 2047, so a decrease of 13 years. And if you look at many technology prediction, typically it's the opposite. People believe that it will happen very quickly, that we will have flying drones, that we will have autonomous cars, but it takes much longer to arrive. Whereas for the AI predictions, basically we tend to believe that they will happen quite far in the future, but the progress tends to be very quick. And the predictions by these researchers is that by 2116, basically there will be full automation of labor. That means that all human jobs can basically be performed by machines. So now, over the next years, here they list also a couple of tasks, and I want to highlight a couple of those and what we can expect the next year. The first one is, when will AI be able to write good high school history essay? And this happened already, and I can confirm this because I have 2 sons, and they're also going to school, and they've been able to create a good history essay and also to get a good grade at their school. So this works pretty fine already today. Now, in a few years, then there will be the prediction that the AI will be able to generate songs that will end up in the charts, top 40 charts. There is also the prediction that in less than 10 years, AI will be able to beat all the best human players by training on a smaller number of games. The AlphaGo program needed millions of games until it reached this level. And the prediction is that in the future, AI will be able to come to this level much faster than a human can. So the AI will be able to learn faster than humans actually can. And for this conference, a very important prediction is that in less than 10 years, the AI should be able to find and patch security flaws. Why important? Of course, because there are many things that we do here in Bug Bounty, or we do also at the Cyber Defense Campus, are finding vulnerabilities in software and finding the patch. And it's also the prediction that AI will be able to do this better in a few years than humans can. And in fact, there is an organization called DARPA in the US that has launched a challenge last year that is going on for 2 years, and they are spending quite a lot of money on this, $40 million US dollars. DARPA is well known for many inventions. It's the defense innovation unit of the US. They have invented, for example, the internet, the GPS, also stealth technology. So they have a very strong track record in inventing new technologies, and they're betting quite a lot of money on AI to do exactly this, to find vulnerabilities in code and also to automatically generate the patch. And why are they doing this? Because they also believe, the US politics believes that there will not be enough human labor to actually patch all the software vulnerabilities we have in our code, in our critical infrastructure. There's just way too many vulnerabilities around that humans will be able to find all of those and also to produce the patch. There was a semifinal I've been attending this year at DEF CON in August in Las Vegas, and they managed to find 22 new vulnerabilities, but more interestingly, they managed to also, the best competing teams, they managed to also patch 15 vulnerabilities automatically without human intervention. So this is, for us at the Cyber Defense Campus, a very key, important question, but I think for the whole society, is what will be the role of artificial intelligence in cyber security in the future. And we have been doing this year a survey, a literature survey, to understand also how is actually AI used today in cybersecurity. And you may know the NIST cybersecurity framework. It has 5 categories, from detect on the left, identify, protect, response, and recover. And our survey basically looks at how many papers, how many applications of AI are there for each category. And what's interesting, it's a decreasing trend from left to right, which means that the most usage of AI today is in this identification, detection part, but very little use of AI to protect, respond, and recover. And you could say in that case that there is an untapped potential for AI, because this may also, if you look at the whole cybersecurity framework and what cybersecurity is about, there is still a lot of, or there's not so much use today of AI in these areas. But this is something we should think about. And this is something we have been thinking about for a few years now. And this is an example of our efforts towards automated cyber defense. There is a center from NATO in Tallinn, in Estonia, that organizes every year a cyber defense exercise. And Switzerland is participating every year in this exercise. And basically, you have a team in the middle that participates. They have to defend their own infrastructure. There is a blue team, the defenders, and a red team attacking this infrastructure during 2 days. And there are hundreds of attacks going on. But basically what the team, what is doing, there is some inputs, sensors, and then you can do some actions, actuators. You can file, you can block, you can add filters at your firewall, you can patch your software, you can reconfigure and so on. And the events would be intrusion detection systems, logs, whatever inputs you get from other channels. And today, these teams are basically human beings, and the teams have become larger and larger over time. Now these teams can be as large as 100 people trying to coordinate and to defend against these attacks. And what we have been developing over the last years is some systems that would basically do this automatically. This is this respond and react part of the NIST framework. So basically you would take all these inputs and analyze them automatically, and then apply some actions to protect your system, to maintain availability, and to protect your data and your availability. So this is of course a very long-term vision, and this is not possible today. But the key technology that should make this vision much more reachable is large language models. So large language models are part, or it's part of generative artificial intelligence. And these large language models provide a lot of the features and the reasoning and the things we would need to implement this automated cyber defense. And this is why last year we have been doing a study on the impact or the role of large language models in cybersecurity. This is the book. The study is now published in a book since this summer. It's open access, so you can download it for free. And it's a study that we have been performing with many different experts, with 30 experts, international experts in AI and cybersecurity, and to understand what is the potential of large language model, but also what's the threat if you try to use the techniques in cybersecurity. What's the mitigations, what's the exposure, and what's the mitigation you can apply if you start using these large language models in the context of cybersecurity. So why a study on this topic? Because large language models is becoming more and more relevant, more and more powerful, and many people start to deploying large language models in various use cases, not only in cybersecurity. But the problem is that many times the security is not really well thought through, and people just deploy it because it seems to work. And there are many open questions, and this is exactly what we want to address in this study, to understand the limitations of these large language models in terms of cybersecurity. And we find many of these limitations. Some are kind of already known, some are a little bit more of a surprise, maybe. So first, the first limitation is that they can only know things that they've been trained on, so there are no way to generate new knowledge. There is the problem of hallucination, discrimination. They are also not factual. They can really reveal private data they've been trained on. They cannot think logically, and they also forget quickly. So these are the fundamental limitation of these models. But despite this fact, they are being increasingly used by attackers to accelerate actually their cyber kill chain. If you look at typical cyber threats like phishing, fraud, social engineering, disinformation or classical cyber attacks. We see more and more people starting using large language model to making these attacks more effective. For example, in phishing, this is on the left, an excerpt of a real phishing attempt, which start with "Thank you very much for your kind words as the large language model of me. I don't have feelings or emotion." Basically, this is some text that an attacker has created automatically by using a large language model. And of course, because he wants to make the input or the text that are sent that is sent over email as realistic as possible. And that's why these large language models are being used. It's also possible, as we see, for example, here, with generative AI to create, for example, a web shop. This is a web shop completely created from a large language model, where you have products that do not exist, picture of products, prices, and so on, that will be tailored to the particular target that would be interested in this kind of shop. So as you can see, this is the typical things that we see, and attackers are being used more and more. This is from the attacker side. On the other side, as I mentioned, there is the increasing trend of using these large language models and by integrating them in current systems. But the challenge is there, if you have a critical system or a system with sensitive data, it's very challenging to protect the confidentiality, integrity, and availability. So typically the typical architecture, as we can see here, you have users that will create prompts with an LLM, but then it will create server-side functions and also access databases and so on. And to make this whole secure is a very challenging problem. Because of all the possible attacks that you can have on large language model. This is, for example, here the OWASP top 10 type of threats and attacks that you can have on the systems, showing you can have this prompt injection, insecure output, and so on. And you can also reveal secure private information from this large language model. So basically integrating those large language model in application can be very difficult. But the key insights of our study is that actually it's not trivial to protect the system in terms of availability, confidentiality, integrity. It's not trivial at all. There are not so many standards at the moment, and the standards lag behind the deployment. That we can see many companies start to integrate these large language models, but there lack security standards to make those deployments secure. Of course, also there is this trade-off of local large language model and remote large language model using ChatGPT or having your local model. And of course, it's much more preferable for security sensitive organization like the military or the public, or in medicine application, health application, to use a local model. So this makes it much more secure. And also it's possible to test application with red teaming, like we do pen testing and so on. With a typical IT, we can also do red teaming with large language model. It's necessary, probably, but it's also not sufficient, because it's really impossible at the moment to find all the issues if you have a large language model. So all the security issues. So basically you can only scratch the surface at the moment. So the study also recommends security countermeasures. What can you do against this kind of problems? And here is a list of the main things that you can actually do if you want to apply and use large language models in the context of cybersecurity. You should first, of course, train the users and also the developers that are integrating those systems. Also, it's a good practice to have some secure training of large language model. Basically, not only training the model like this, but having some also security in the training phase. It's also good. It's also possible in some case to detect if text or if images have been generated by large language models. So this is also something that there is some research, and that could be also used, some detectors of automatically generated content. Also the use of local large language models instead of using ChatGPT or the other models that are in the cloud, to use your own and basically have their better protection. And what is very important, of course, is the ability to test the large language models in terms of security. And this is what we have been also thinking a lot at the Cyber Defense Campus. How can we actually test these applications? And this year we launched Startup Challenge. We have every year a Cyber Startup Challenge. That's a challenge in the area of cybersecurity to look for new ideas and new innovations in the area of cybersecurity. And this year, the goal was to find new products, new ideas that will allow us to test large language models for the security. So every year, we award 100,000 Swiss franc to the startup that we believe has an interesting approach, a new approach, and we do a proof of concept then with them. And this year we had an open international call, over 40 international startups participating in a startup challenge and proposing their solutions to how to test and how to make LLM applications more secure. And the finalists, they were presenting a few weeks ago at the Cyber Defense Campus conference. These are the three finalists. These are basically the three solutions that were considered at the most promising to do this kind of evaluation. The first one is Patronus AI. We have also Dynamo AI, two US startups, and QuantPy is a German startup. And this basically solution convinced the jury that they would have an approach that would be possible to do LLM evaluations. All three of them can do some evaluations. Dynamo AI can also do some guardrails. That means that you will use their product between the user and the LLM provider. If it's in the cloud, for example, to guardrail, to have some filters, like you would have a firewall, you would basically have a system there doing some filtering and checking the input and the output. And the QuantPy was also a startup also focusing not only on the evaluation but also on the compliance. There is also now European legislation regarding the use of large language models. This is also a solution to test the compliance of your models. So we have selected Patronus AI. This is the company that we will build a proof of concept, and we will also use to evaluate systematically the security of large language models that are around, and also large language models that we may tune ourselves next year. And this product basically allows us to evaluate different things like hallucinations, prompt injection attacks, also the bias, toxicity, the OWASP risk I've shown before, also the alignment, what kind of style do we get answers back. So this is a very flexible way how to test large language models, and this is what we are going to do next year. With that, I want to thank you for your attention. I want to make a small advertisement also. I don't know how many students are in this room, but we have also a fellowship program. It's an open fellowship that is open to any student in Switzerland that wants to do a master thesis or also a proof of concept when you're done with your studies and you have a good idea to implement a proof of concept. So there is also a rolling call for PhD and postdocs. But in many of applications that we receive in the moment and in the area of AI and how to make AI more secure. And it's not the only possibility. We have also other possibilities in cybersecurity. But we believe it's a very important topic. And if you're interested and have a good project or idea that you would like to do in this context, you could certainly apply. It's in collaboration with EPFL. But this program is open to any Swiss university. With that, thank you very much, and I'm happy to take questions.
Will we now go more to kind of specific AI before we become like the big HI, or like the design of those artificial intelligence bots kind of be like the same for mother AI and then like sub-tasks, or do you see kind of trends in that? Like some meta-specific AIs and like the modern one that just steers towards the best one that can deliver the task, or it kind of will be the HI just really one model that can handle all the things?
Okay, so you mean the foundation models for the large language model? Yeah, it's difficult to do predictions. At the moment, there are specialized models that perform better in some areas than others, and then there will be the question if this will remain the same in the future or not. But at the moment, I would say yes. That's probably more efficient to train in a specific domain than to come up with a very generalized model. Although these systems, these agents, conversational agents that you have, there is also some training part. Basically, you train on a lot of data to create the foundation model, but there is also a lot of reinforcement learning going on. And this is basically training on the user input and how the user behaves after he gets the answer. And this is also very important. And of course, if you scale better, if you have a large user base, this is also much. It will also improve a lot the quality of your conversational agent. So I think there are these two things: the quality of the data you will train on, but also the user base that you will be able to fine tune your models later and your answers later on. Yes, please.
When it comes to integrating LLMs in current infrastructure, for example, like you said, you gave some examples where people already implement backend APIs and so on. Do you think it makes more sense to focus on the overall architecture of where exactly the LLM stands and what access the LLM has to the overall infrastructure, or the security of the model itself? For example, to some of these startup projects you described.
I think you have to do both. I think you have to do both. You need to protect, the different attack vectors you can attack this. So I think it's like this all lost threats. You need to basically address all of them, because the attacker will typically attack the weakest link. So I think there is some work to do on secure training, on filtering the prompts, the output, but also on securing the whole architecture.
Yeah. For example, some of the OWASP can completely become irrelevant if you don't hook the LLM with sensitive APIs or backend. So this is, in my opinion, a good starting point. So first should be a threat model, maybe an evaluation of what the LLM can access, and then secure the LLM itself.
Yeah. I agree, but what we see is that many people start integrating them without this very sophisticated security analysis of threat model. So I think that's a little bit the risk at the moment, that the development and deployment goes much faster than all the security architecture that lags behind. Yeah. Yes.
Thanks.
Further questions now? Then thanks a lot for coming, and have a good afternoon. Bye bye.